Hello everyone, my name is Abhinav and I am working as a BMS algorithm development engineer at Decibels Lab since 2021. In this video, we will see what are the different commercially available lithium-ion chemistries, that is, what are the different variations of lithium-ion chemistries. So, we will start with the first one, that is lithium cobalt oxide, which is one of the most earliest rechargeable lithium chemistries introduced in the market, followed by lithium ferrophosphate, also abbreviated as LFP. So this is a variant of the existing lithium-ion chemistry. And then we'll come to the derivatives of lithium cobalt type batteries, which is lithium nickel cobalt aluminum oxide and lithium nickel manganese cobalt oxide. And then we'll also explore one more, that is one of the more modern type cell chemistries, that is lithium titanate. And one by one, we will see all of the cell properties along with their voltage curves. So let's start with the first one, that is lithium cobalt, also abbreviated as LCO. So here you can see on the left-hand side how exactly the voltage curve of the particular cell looks like. So if the cell were to be subjected to a constant current discharge, that is to say, if you were to discharge the cell at a rate at a constant current or rather at a constant rate, this is what the voltage curve would look like. So on the right hand side, you can see some of the properties, starting with the nominal voltage, that is at 3.6 volts. And at that time, this cell was one of the most powerful cells available, with 3.6 volts available in a very small form factor. So apart from that, there was also very high gravimetric energy density available. So almost up to 200 watt hours per kg, depending upon what is the concentration of the chemical materials inside the cell. And it also boasted a very good cycle life of up to almost 1000 cycles, which promised more than 3 to 4 years of good usage before end of life. So this had primary applications in handheld devices like cordless phones, wireless phones, and some satellite-based mobile phones, cameras, handheld cameras, and laptops. So next, coming on to lithium ferrophosphate, so abbreviated as LFP. This is a variation of the chemicals present inside the lithium cell, basically switching the cathode material from cobalt-based material to iron-based material or iron phosphorus-based material. So on the right-hand side, we can see what are the different properties. It has a nominal voltage of 3.2 volts. So this is a slightly lesser voltage compared to lithium cobalt-based batteries, and also a much lesser gravimetric energy density because it no longer has cobalt or nickel inside the cathode. Instead, only has iron and an iron compound, right? So meanwhile, it's having a much higher cycle life of up to almost 4000 cycles. So this was introduced in the year 1996, and for a time this was one of the best available lithium chemistries, and is also considered as one of the best cells for EV-based applications like electric cars, electric bikes, and even up to backup energy storage devices. So on the left side, you can see how exactly the voltage curve of lithium ferrophosphate cell looks like. It is a much more stable curve compared to lithium cobalt, suggesting that lithium ferrophosphate is a very, very stable chemistry and is one of the best or one of the most preferred chemistries in today's EV market. Next, coming to lithium cobalt aluminum or lithium nickel cobalt aluminum, which is the derivative of lithium cobalt oxide batteries. So this actually has an additional two set of elements apart from cobalt in the cathode material, that is aluminum and nickel. So this is basically to stabilize the reaction further and to give a much long-lasting life to the existing batteries. So earlier prototypes actually had a cycle life of up to 1000 cycles, but in today's modern standards, they have a much higher cycle life, coming to almost 2500 to almost 3000 cycles depending upon the operating conditions. So this has almost the same set of nominal voltage, that is at 3.6 volts, once again allowing it to have a much higher gravimetric energy density of almost 300 watt hours per kg, making it one of the most prominent cells and most prominent cell chemistries in today's EV market. So most prominent users are MG, Tesla, so specifically Tesla Model S and Model 3, and many high-powered industrial equipment also use NCA, because mostly these are used for high-powered devices. So on the left hand side, you can see how exactly the voltage curve looks like. Again, if you subject the cell to constant discharge or constant current discharge. Next, coming to another derivative of lithium cobalt oxide batteries is lithium nickel manganese cobalt oxide, often abbreviated as NMC. So here the cathode material is having a slight variation in the chemical composition from aluminium to manganese. So once again, manganese has been added to make the reactions much more stable, not only chemically but also thermally and even structurally much more stable. So here it has a slight increase in nominal voltage to 3.7 volts and has a gravimetric energy very similar to that of NCA type batteries of almost 250 watt hours per kg and boasts a cycle life of almost 2000 seconds. So this was introduced more recently in the market by around 2008 and once again has very prominent usage in today's EV market, from e-bikes to hybrid to full electric vehicles. Even some of today's modern high-performance sports cars also use this kind of battery because this can support of up to very high current discharge rates and also supports very high charging rates. So here on the left side, you can see how exactly the voltage curve of the particular cell looks like. So you can see that it supports a very large voltage window coming from 4.2 volts to almost 2.7 volts. And some of them can go as far low as 2.5 volts. So almost more than 1.7 volts worth of available voltage window, and therefore more available energy is available in such type of cells. So coming to the more modern type of chemistries, that is lithium titanate, has been very recently introduced and has a nominal voltage of 2.4 volts and a gravimetric energy of 50 to almost 100 watt hours per kg. Although it is having much lower energy compared to other lithium-ion chemistries, its cycle life is predicted to be much more than 10,000 to 12,000 cycles, giving it almost more than 10 years worth of usage. So once again, this has been more recently brought about. So the complete availability and the complete usage of such cells has not been thoroughly investigated and it is still under analysis. However, it is a very promising future candidate for replacement of existing lithium-ion cells and can surely be much more sophisticated once some more additives and some more research has been done on such type of cells. So in this video, we have seen what are all the different available lithium-ion chemistries in today's market, and the most prominent ones are LFP, NMC, and NCA. LCO cells are no longer used because they are outdated and they do not serve the level of energy demand nowadays. Instead, their derivatives of NCA and NMC are used. So with that, we end this video. So I hope that this video was very useful for your knowledge. So this is how we classify different lithium-ion cells in today's market, and this is how we classify the list of available lithium chemistries. Thank you.